Hello everyone. Welcome to lecture number 7 of Fundamentals of Computing, which is on Central Processing Unit, that is CPU. In this lecture, I'll cover the following topics. First one, the definition of a Central Processing Unit means what is a CPU, functions of a CPU, components of a CPU, types of CPU, and lastly memory hierarchy. So let's start with the definition of a CPU, that is the Central Processing Unit. CPU, this is also called as a processor or microprocessor. It's considered as a brain of a computer system. Why it considered as a brain of a computer system? Because data is processed in CPU. We get a data input through the input devices, and that has been processed through the CPU, and after that we get the information. It executes the instructions of a computer program in sequence. CPU does calculations, that is it will perform arithmetic logical operations, that is addition, subtraction, multiplication, plus it controls the transfer of a data among devices. The main components of a CPU are ALU, that we call arithmetic logic unit, which performs arithmetic operations like addition, subtraction, multiplication, division, whereas logical unit, or we can say logical operations, are AND or NOT operations. Second one is the control unit, that is the CU, which fetches instructions from memory, decodes them, and determines the address of data. Another component is the register set. It is a small fast memory location where the data is stored, and that data can be easily, or you can say fastly, accessed by the CPU. So this was about the Central Processing Unit, that is the CPU. Nowadays, you might have heard about the Intel and AMD. These are the two most popular CPU manufacturers for desktop, laptops and server, while Apple, Nvidia and Qualcomm are the big smartphone, tablet CPU makers. The main function of the CPU is to process the data. It will take an input through the input device, then this processor, or we call the CPU, it does processing. That depends upon the instructions that has been given to the computer, and then it will produce the output that we call as a information, and this output is seen in through the your output devices. So what this does it during the processing? It may either perform arithmetic logical operations, that is a plus, multiplication, subtraction, division, modulo, anything, or a logical operation, that is the AND or NOT. Apart from that, there is a control unit that fetches the instructions from the memory and transfers the data from one part to the another component of a computer. So that I already told, it fetch an instructions from the memory, decode the instruction, and lastly execute the instruction. So this was about what you can say the main function of CPU, or you can say Central Processing Unit. These are the different types of CPU, or you can say processor, which are available in the market. Nowadays, you can see what you can check this single core dual core, quad core, hexa-core, octa-core, deca-core, and the multi-core. That depends upon the number of cores in a processor that can execute the instructions independently. So single core obviously means what, the single processor, dual core means what, the two processor, quad core means the 4 cores, hexa-core means the 6 cores, and octa-cores means the 8 cores, and so on. Further, this can be also classified as 32-bit CPU or 64-bit CPU. So this was about the types of a CPU depending upon the cores or the bits that has been used, 32-bit or 64-bit. The components of the CPU are arithmetic logic unit that I already told. It performs arithmetic operations and the logical operation. Arithmetic operations includes the addition, subtraction, multiplication, division, whereas the logical operations includes and or not. Second one is the control unit that interprets the instructions and initiates action to execute them. Apart from that, it also coordinates data flow within the CPU and between other computer components. Third one is the registers. Registers are high-speed memory location that is used to store the data which is required by the processor for processing. Cache, it is a type of a memory and its capacity is smaller than that of the primary memory. It stores frequently used instructions and data for quicker processing by the processor. Obviously, its access time is less as compared to the primary memory, or you can say RAM. Next one is the clock. Clock is nothing but every processor system has a clock. Why we have the clock? Because it is used to synchronize various operations that take place within the computer system. Next is bus interface system. Its function is to transfer a data between the different components of the computer and other parts of the computer. So what are the main components of a CPU, or you can say the processor? It's ALU, that is arithmetic logical unit, control unit, registers, cache, clock, and the buses. From this diagram, you can understand how the data flows from the memory and to the CPU where this gets executed. So if your data is stored in the hard disk, so it has to be transferred into the RAM first, because I already told you anything you want to execute, it has to be loaded into the RAM first. Once it is loaded into the RAM, after that in the main memory you contains you have a program which is nothing but what you are going to do on the data. It is nothing but, or you can say, set of instructions given to the computer to perform a particular task. So this program is then converted into the instruction format, which is the mode, opcode, and operand. Then this is submitted to the CPU, and after that CPU will do processing. This processing involves what? Fetching the data, decoding it, executing it, and store it in the memory for further use. So from this diagram you can understand how the processing, or you can say data processing, is done by using the CPU. This is another diagram to demonstrate the same thing. Here we have the main memory, cache memory, CU is the control unit, ALU is the arithmetic logical unit, secondary storage devices, input and output devices. So what exactly does? First the CU fetches, decodes and executes the instructions. Then it issues control signals that control hardware components within the CPU. ALU is what? It acts as a gateway between the primary and the secondary storage. So data transfer between them passes through what? Through the ALU. In this way, the CPU works, or you can say the different components of the CPU works, especially the ALU and the CU for processing of data. The another important component of the processor is bus. So we have the three type of buses: address bus, control bus and the data bus. So let's just start with the address bus. Address bus, this is used to identify the memory location. Memory location means where the data is stored. So why we need that? Because processor wants to access the data from the memory on which it will do the processing. So that data is stored somewhere. So for that we should have, if we know the address of that, we can directly access it from the storage devices and that will be given to the CPU. It's a unidirectional path because it carrying addresses from the processor to other components. So this is what your address bus. Here the processor knows the address and wants to get the data that can be either stored in the main memory or in a disk. So if we know the address, we can get the data that has been stored over there through the address bus. Next one is the control bus. Control bus, from the name itself, what it is controlling something. So what is this controlling? Here it carries control signals that manage the timings and direction of data flow that is required for proper synchronization and coordination between the processor and other components. It's also a bidirectional, allowing the processor to both send and receive control signals. Third type of bus is the data bus. So data bus is what? That actually carries the data that has been transferred between the processor, memory and other components. So it's also a bidirectional path because data can flow in either direction. So this was about the different type of buses that use: address bus, control bus and the data bus. Once we know what is CPU and what are the components of the CPU, then the next question comes in our mind: which processor is more suitable for us? So for that, we should know on what factors the performance of a CPU depends. So these are the following factors. Number one is the clock speed. Clock speed means what? The number of instructions executed by a processor per second. It is usually measured in gigahertz. So the processor whose clock speed is high is obviously considered to be the fastest processor. Next one is the number of cores. Number of cores means what? What are the cores? Cores are nothing but these are the independent processing unit within the processor. So if we have a more number of cores, it means what? More number of instructions gets executed simultaneously. Cache size. Cache is a high-speed memory that stores the data which is required by the CPU for execution, or you can say for processing. So if the size of the cache increases, obviously it means what? You can store that much of data which is currently required by the CPU. It need not to look that data into the primary or the secondary memory. So in that way the access time for getting that data gets reduced, and because of that the processing speed will be faster. Next is the instruction set architecture. It defines the set of instructions that the processor understands and can execute. If we have a wider range of instructions, then obviously it can lead to the faster processing. Next is the power consumption. Obviously we go for that type of a processor which needs less power consumption. Thermal management processor emits a heat, or you can say generates a heat. So in the case of the supercomputers, we have a more number of processors, so the heat generation will be more. So we need air conditioning for cooling it. So if we don't cool it, then it may lead to the damage. So therefore thermal management also considered as a factor for the best performance of a processor. Once we know this, then nowadays you might be heard about the Core i3, Core i5, Core i7, Core i9. So these are the different type of the CPUs. So what are these? Single core processor, from the name itself, it means what? There is only a one core. So it means what? One instructions can be executed at a given time. So it is mainly used in the desktop and by the single user, where the processing speed is of not that much required. So in that particular case, a single core processor can be used. Second one is the multi-core processor. Multi-core processor means what? It can be split into two or more sections of activity, with each core carrying out instructions as they were completely distinct computers. So it means what? More number of instructions gets executed simultaneously. In this, the cores are located together on a single chip. This multi-core processor, it may be dual core processor, quad core processor, or you have the octa core processor. In the case of a dual core, from the name itself, it means what? The two cores. Quad core, it means what? It has what? The 4 cores. Octa cores means what? The 8 cores. Nowadays we have the hexa also, that is 6, then deca, that is a 10. So these are the various multi-core processor. As we increase the number of cores, obviously the number of instructions that are going to be executed at a given time will be increased, and this will fasten the processing. Another one of the CPU is the embedded processor. Embedded processors are expressly engineered for use in embedded system. These are designed for to perform a specific type of task, like your smartphones, digital cameras. In that we use the embedded processor. Obviously it has a low capacity in the terms of what the lower speed, and it consumes less power. So this was all about the different types of a central processing unit, or you can say the processors. Next we go through the memory hierarchy. What is memory hierarchy? It is nothing but it refers to organizing computer memory into a structure where different types of memory like register, cache, main memory, secondary memory are arranged on the basis of their speed and cost. So at level 0 we have the CPU register, which is considered to be the fastest memory and it's a low capacity. At level 1 we have the cache memory, Level 2, we have the primary memory or main memory. At level 3, the secondary memory or magnetic disk. At level 4, there is an optical disk or magnetic tapes. It means first we have the CPU registers. CPU register means it is the where the data is stored temporarily and which is required by the CPU for its processing. It is faster than the cache memory. Cache memory is also used for the temporary storage. It is also a high speed memory but low capacity. Then comes primary memory, that is your RAM, that is random access memory. Then comes hard disk, after that optical disk and the magnetic tape. This at the same level. So at level 0 we have the CPU registers, level 1 we have the cache memory, then level 2 we have the primary memory, 3 we have the hard disk, and level 4 we have the optical disk and the magnetic tape. The CPU, cache and primary memory are expensive as compared to hard disk, optical disk and magnetic tape. This has the less access time, smaller in size, and because of that its capacity is less, and this is used for the temporary storage. It means what? Once the power goes, then the data will no more. Then the secondary memory, this is the hard disk, optical disk and magnetic tape, which is at level 3 and level 4. These are less expensive as compared to what the memories which are at level 0, 1 and 2. It has a more access time, larger in size, and because of that it has a large capacity to store the data. Another difference is what? It stores the data even when power is off. The cache memory, it may be your L1, L2 or L3 cache. So what are these? L1 is considered to be the smallest and fastest of L1, L2 and L3 cache memory, and it is directly integrated into the CPU chip, and because of that it is considered to be the fastest one. Capacity wise, the amount of data that it can store, that varies from 16 KB to 128 KB. Next comes the L2, which is larger but slower than the L1 cache memory. It is often integrated into CPU chip but can also be on separate chip near to the CPU, and its capacity is larger than the L1, that is ranges from 256 KB to 1 MB. Next category of a cache is the L3. It is the largest but the slowest among these three, and its capacity ranges from 2 MB to 32 MB. It is used in high-end processors. So this was about the different type of memories that has been arranged according to their speed and the cost. This diagram shows the memory hierarchy. From here itself you can see that once we go down from CPU register to the optical disk and magnetic tape, what it will do? It increases the capacity and the access time. While when we move from magnetic tape towards the CPU register, it increases in cost per unit. So this was all about the memory hierarchy. So in this we have discussed the CPU, different type of CPUs, components of a CPU, and the factors or the parameters which are used to decide the or check the performance of the CPU, and the memory hierarchy. Thank you.